Hello, I am Luis Velarde. I'm the head of cloud and infrastructure architecture within Telefonica. And the idea of my presentation today is, since we are talking about cloud native and the telco cloud native, trying to describe why we need a telco cloud native, what are the requirements, then what are the challenges, but some of them have already been described by James in his previous presentation. So I want to describe some of the challenges, not all of them, but at least those that I find more relevant. And then how open source and standards bodies like ETSI can help, because on the contrary of the previous presentation, I think Silva is not late, it's come at the right time, so I think it could help us. Okay, so the thing is that it all starts, why we need a telco cloud native? It all starts with services. In the end, we are operators and we need to provide services to our customers. And the thing is that the services are changing. So what the customers are expecting is changing. And our infrastructure is basically the enabler for these services. So we need to accommodate the new services, the new demand that is coming with 5G and the edge. And these new services come with specific requirements that are on demand, basically. There's on demand timing, on demand location, and on demand requirements. Basically, a customer wants his specific service to be provided whenever they need it and wherever they need it. And typically it needs to be close to himself, to the customer. The customer really doesn't know where it is happening, where it is being processed, but this is one requirement we will see later. But they need it when they want it, where they want it, so when they are, where they are, and with their specific characteristics. And the telco multi-cloud in general, not just the cloud native, but the telco multi-cloud is we can define it as the set of virtualization environments where all the computing resources, all the infrastructure, all the elements that allow this infrastructure to enable the services are being provided and are being served by all the workloads, so that we have everything that the customer needs. And this means that in order to cope with the service requirements characteristics that I commented before, needs to be multi-site because it has to be distributed around the footprint, has to be close to the customer. The customer, again, I repeat, doesn't know where the processing capability is, but it has to be close to him just to serve with the required latency. So it has to be multi-site with a distributed topology. It has to be hybrid, public or private. In the end, the concept of public or private actually dilutes. It's cloud in general. So we need to have the sites that I need. Maybe it's public because for a specific service or a specific functionality, the processing capability can be far from the customer, so a public environment is good enough, or maybe not. I need to have it close to my environment. So private or on-premise, let's say, and public or further is diluted. So it must be hybrid. And it should be multi-vendor because, or vendor agnostic. We don't need a vendor lock-in. The services require specific capabilities. Every vendor may provide improvements for some capabilities, but we should be capable of allowing all the options. So these are the main requirements, the main characteristics for the telco multi-cloud. But this is the telco multi-cloud. So in the end, things that we need are, we have it listed here. What I have commented is resolvable. This is basically repeating what I've just commented. We are actually, with this multi-site, multi-vendor and hybrid environment, we are tackling the characteristics or the needs from the services. So the on-demand timing will be resolved because in a multi-site, as I said, we will resolve that. The on-demand location, the distribution also, but also the hybrid, because it will depend who can provide me the specific services. The on-demand requirements will be covered by a multi-vendor environment. Maybe there's a vendor that provides very good synchronization for Open RAN requirements and a different set of characteristics or capabilities. So having a multi-vendor environment provides a response to the on-demand requirements. And finally, efficiency is something that is overall, all the characteristics improve the efficiency, which is in the end something that we are all looking for. So what we need is to be capable of deploying what we need, where we need, always in the best side. As it has been commented by Carlo before, in the end, a decision-making algorithm could be deciding where is the best place to deploy something. So we should be capable of doing it in that way. And we are moving more, it's not only network functions, because we always talk about telco cloud for network functions, but this architecture is for any workload. In the end, it's not just network functions, it's also IT applications, edge applications, Open RAN, the transport, when the networking and the transport themselves, the switches can be virtualized and containerized. So we are not just talking about how to resolve a telco cloud for the network functions. This architecture is valid for all the different domains. Of course, we may need some segmentation because since characteristics or capabilities or requirements may be different per domain, we may need to segment, but this segmentation should be done dynamically. So this is very interesting. This is the telco multi-cloud. We need multiple sites. And what do we need for that? What we need is three main operations. We need workload placement, we need workload operation, and we need workload portability. Workload placement basically tells us where do we need to deploy something. So since we are in multi-cloud environment, hybrid, and as I repeated several times, multi-vendor, we need to decide which is the best place for each workload. We need also tools or mechanisms to operate this, because once we have everything deployed, we have to maintain it. It has to keep working and always in the best side. And even being in the best side may mean moving it from one cloud to the other. Carlo commented before, portability is a very important element. Maybe it's not part of the cloud principles, but it's a requirement for us. So we need to support workload placement, operation, and portability. And these three elements actually is something that is resolved with a cloud native. So if we follow the principles of a cloud native architecture, we are resolving the multi-cloud telco requirements. This means that we need to follow this code with these requirements. We need on-demand activation and removal, of course, because it has to be dynamic. This is something that we may need an application to be living in a site just for 2 hours. If it's an application for a video game, only while the user is using it, we need it in that location. So it should be on-demand activated and removed. We may need a scalability and elasticity because we don't know how much resources we need. In the end, a distributed environment is a common pool of resources. We need to accommodate this pool of resources and configure it accordingly to the needs, to the computing needs for each area, for each location at the right time. It should be intent-based because we need not just deploy but guarantee that it is still alive. So we have to do reconciliation if we identify that not everything is as it should be. We need portability because, as we commented before, maybe we determine that a given site is no longer the best one, so we should be able to move it to another site. But not only that, different operators or different moments when you want to deploy, maybe the best sites is provided by different vendors or has different characteristics. So our application should be capable of being portable from one vendor to another, from one site to another, because we need to move it in different times or through the use of this application. And of course, it should be a standard because we are talking about something that is being distributed, being relating different vendors, so we should follow standards and open source, as it has been commented many times before. So these are the main requirements of a cloud-native telco that resolve all the things that we commented. To do this, we need two specific components. a multi-cluster manager and a workload deployment manager. I talk about multi-cluster manager because mostly we are moving into a world of containerization. Of course, we still have virtual machines and all that, but probably the more and more we will have containers. So the cluster is basically the environment where applications will be running. So we need a multi-cluster manager and a workload deployment manager. And we need interfaces to be standard about this. So basically, the situation is that someone will design, this is the architecture of a cloud-native telco. A decision algorithm or whatever identifies which is the best site to deploy something. And before deploying it, has to confirm that we have the environment to deploy it, because we cannot deploy it on the air. We have to deploy on some hardware that is configured for that specific application. So first of all, there's a need for the point one and the lines 1 and 2. And it's not a continuous line because maybe it's not needed, maybe it already exists. But if it does not exist, someone has to tell this multi-cluster manager that we need a new infrastructure there. This, we call it multi-cluster manager, could be part of Silva, could be part of NFV. We will see how this element, we can discuss about that, but it's a multi-cluster manager, something that is capable of creating the infrastructure. Once we have it, then we have to deploy the specific code image dynamically. And this is a workload deployment manager. And then we will have it in the site, in a different site, or whatever. And finally, we may need another component, it's not in the image, that moves or processes the portability when required. But I have not added in this slide to make it more complicated. So, this architecture, this is the cloud native, but can we do it today? Well, there's some challenges. We still are not mature enough for different things. First of all, the stacks need to be ready. We need stacks, infrastructure, environment, container-based cases, platforms that support all the requirements for all this, support all the requirements for the different domains. We need SLOB, pass-through, all this PTP support that was commented for Open RAN domain. We need automations, GPU support for video-related applications in it. So the stacks still are not completely ready, or at least we have to evaluate for the different domains. We also need the workloads in general to be cloud native. This is something that has been commented before. I think everyone has already commented. The workloads are not cloud native. Being cloud native does not mean just putting software in a container. It means having portability in mind, as I described, or being vendor agnostic, these kind of things. There's work from application providers to be done to support these requirements. Today is not mature enough. We are not designing with the mindset of cloud native. This change of mindset is required. And finally, we need the tools and interfaces to manage this multi-cloud environment. I talked about the multi-cluster manager, workload deployment manager. We need to standardize all together which are the interfaces. Cluster API was commented, is probably one option to work in a multi-cloud environment, multi-vendor environment. These are, there are more challenges, but these are three main challenges that I identified to make all this happen in a near future. So, after we discuss the challenges, why Silva and ETSI can help? Silva can help because it tackles some of these challenges. Silva specifically is releasing a cloud software framework and is developing a reference implementation. So, since we are building a reference cloud native stack that incorporates already some 5G requirements, the data plane requirements, now we are working in the Open RAN and supporting GPU as well for some edge applications. So it's defining as a reference, so it's indicating what needs to be added there. So if we have a stack that abides by the Silva definition, then it's closer to cloud native. It's helping us to understand what being cloud native means, what requirements are needed in the stack. But it's also providing a validation program, as been described before by Guillaume, is providing a validation program where application providers can demonstrate that they are cloud native because they can deploy not in their specific stack, not as a virtual solution, but in a reference cloud native stack. So if they validate here, it means that they can validate in any cloud native stack over there. So this is why Silva, I think, is at the right time, because right now is where we need, maybe not for the control plane of the 5G, but we will need it for data plane, for UPF, for instance. We will need it for Open RAN, we will need it for edge applications, and maybe transport, even transport that is distributed. So many distributed environments will require this. So Silva can help there, first of all, to understand what is needed, and secondly, to allow application providers to demonstrate their solutions are cloud native and are being designed with this in mind. And then we have also standard bodies like ETSI NFV. ETSI NFV already tackles some of the things that I've commented. It talks about the cloud, the CCN has one component called CCN. This is cluster manager. That is like the multi-cluster manager I commented, or similar, or has similarities. And the NFVO, which is like a workload deployment manager. But this still can be evolved. So the CCN can become more multi-cluster manager, more multi-vendor, and keep working on the standardization, and also incorporate the intent-based part, because today the CCN defines very well what is needed to deploy clusters or configure them, but we should incorporate the intent-based, so this reconciliation idea. And actually, there's open source initiatives in this as well that are going into this direction. OSM, ETSI OSM now is evolving to become not only the NFVO as it is today, but also an MCM, a multi-cluster manager, incorporating the intent-based way of working. So it's all going into resolving the three challenges that I commented 2 slides before. And this is basically all my presentation, but there's 3 takeaways. Usually in every presentation, we say that the audience usually only retains 10%. So if you have to retain a 10% or a 5% of what I have just commented in these last 20 minutes, it should be these 3 sentences. They are here. Be cloud native from design. It's important because we have to allow mobility, portability in general. Design with intent base so that whatever you deploy is still alive and no one changes it by you. And use standards, because we need a standardization interfaces common for everyone so that we can, in the end, follow the dream of a federation between different operators. So that was all about my presentation. Thank you.
Thank you, Luis. Few questions.
All right, time here. All right, so I think you emphasize multi-cluster management, multi-site. Second, you mentioned about typical cloud native, right? So requirement. Do you see you already mentioned the difference between the native cloud native and your typical cloud native. The difference you talk about in your slide.
Yes, the difference. Okay, in the end, everyone resolves. So my view of the architecture is the multi-cloud. So we need to work in a multi-cloud environment, taking into account that services are going to be distributed per se and on demand. So we need a multi-cloud environment to go with this on-demand thing. And the cloud-native principles, so technology based on cloud-native principles, microservices, scalability, and portability as well, resolves this scenario. So in my view, the multi-cloud architecture is a telco, is a cloud-native architecture.
Is your vision of more cloud? It's like Carol mentioned before, and cloud continuum. Is this a similar idea or different?
Yeah, if we have a standard definition, if we all have the same language, a common language, because we have reference implementations of what the cloud stack is, and we have interfaces for communication and the tools defined, we can have a cloud continuum. A cloud continuum means that if we all follow the same principles and we have all the same requirements, any application could work in my environment or in another operator's environment immediately, with no needing year time of certifications, which is basically what is taking us time to be agile enough. So the problem that we mainly have is having to certify every solution because they are not cloud native, they are not intended to work in different environments.
Okay, so if time allows, I can ask you during the panel. Okay.
Okay,
All right.
yeah, yes.
So be ready.
Okay, thank you.
Thank you, Luis. So